Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 24, 2025, about 3 days ago. The big result is an approach that generates truly infinite three-dimensional worlds, while achieving state-of-the-art geometry reconstruction and keeping appearance and structure consistent. The paper is titled, WorldGrow, Generating Infinite 3D World, and as we'll see later, the results are really impressive. In short, the method grows scenes block by block, using priors from pre-trained three-dimensional models, a curated block dataset, a three-dimensional block inpainting step for seamless extension, and a coarse-defined pipeline that nails global layout and local detail. So Figure 1 shows how the system grows a world block by block, meaning it synthesizes small tiles that stitch together seamlessly. The top panel presents the pipeline from coarse voxel layout to refined mesh and textured rendering, which highlights the coarse to fine refinement. The bottom panels depict an embodied agent navigating continuous rooms, signaling that adjacent tiles stay aligned. Together, these visuals emphasize scalable, coherent indoor environments ready for interactive tasks. Well, Figure 2 presents the full pipeline that makes infinite scene growth practical, because each module handles a distinct part of structure and appearance. The top left panel adapts structured latents, meaning sparse voxel features that summarize three-dimensional shape, to scene blocks. The bottom left panel illustrates three-dimensional block inpainting, which completes masked regions using context. The right panel then shows block-by-block expansion with coarse-to-fine refinement for globally consistent, detailed worlds. Alright, Table 2 reports visual fidelity for generated blocks, meaning how realistic the rendered images look from multiple views. The method leads on every metric, with the highest CLIP score and the lowest Fréchet inception distance variance, which gauge perceptual realism where lower is better. For example, the inception FID drops to about 30. The Dino V2 FID is about 314, well below competing systems. Methods that output geometry only were rendered with a uniform white texture for a fair comparison. So Table 1 summarizes geometric quality and connectivity, which means how closely the generated blocks match real data and stitch without seams. The table reports distribution metrics like maximum mean discrepancy, a statistical distance that checks if two sets come from the same distribution. Our method leads with a low FID of about 7.5, so perceptual geometry is strong. Coverage reaches roughly 52%, and maximum mean discrepancy is about 0.97, while ablations score worse. Okay, 2 takeaways stand out. Structured block generation with three-dimensional block inpainting and a coarse-to-fine hierarchy delivers stable, infinite worlds, and it does so efficiently on a single A100, enabling sizable scenes in minutes. The implications span simulation, embodied AI, and future world models. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.